Section 11.1.21. A survey asked, how many tattoos do you currently have on your body? Of the 1,252 males surveyed, 174 responded that they had at least one tattoo. Of the 1,337 females surveyed, 128 responded that they had at least one tattoo. We want to construct a 90% confidence interval to judge whether the proportion of males that have at least one tattoo differs significantly from the proportion of females that have at least one tattoo. And then we're going to interpret the interval. Well, first and foremost, what we want to do is we're going to let P1 represent the population proportion of males with tattoos. We're going to let P2 represent the population proportions of females with tattoos. So to construct a confidence interval for two population proportions, P1 and P2, the requirements below must be satisfied. If the samples are obtained independently using simple random sampling, we have the following formulas where that must be greater than or equal to 10, and the sample sizes are no more than 5% of the population size, then the bounds for a 1 minus alpha times 100% confidence interval for the difference between two population proportions, P1 minus P2, are given by the following formulas. Here is the formula for the lower bound, and there is the formula for the upper bound, where n subscript 1 is the sample size for males. The point estimate of subscript 1 is equal to x subscript 1 divided by n minus 1. And then x subscript 1 is the number of males. And the following are the corresponding values for females. And then z subscript alpha divided by 2 is the critical z value. Now, once we find the confidence interval, if the confidence interval does not contain 0, then we're going to conclude that there is sufficient evidence of a significant difference between the proportions. Otherwise, if it's not, then there is insufficient evidence of a significant difference between the proportions. Okay, so the first thing we're going to do is we want to calculate the point estimates. Alright, so if we want to calculate the point estimates, okay, recall what we know for x1 and n1. Well, for males, we know that there is 174 that responded they have at least one tattoo. So we know that x1 is going to equal 174. And we know that the sample size for that is 1,252. And then we want to be able to find the point estimate for the males. Okay, now what we want to do is we want to find the females, so we know that that is where x2 is going to equal 128 that responded that had at least one tattoo out of a sample size of females, which was 1,337, and we're looking for the point estimate for that one as well. Okay, so if we want to find the point estimate for the males, then we're going to take x1 and then divide that by n1, which is going to be 174 over 1252. Now again, we we can divide and find a decimal equivalent of that, but I would recommend leaving it as in fraction form so that we can get, if we round it off now, then it could create sort of a decimal error later on, so we want to leave it as a fraction. Okay, next we have point estimate 2, which is going to be x2 over n2, and so that becomes 128 over 1337. Okay. So now the next thing is we want to evaluate the condition for the first sample, meaning that we want to determine that we're assuming that the samples are obtained independently from a large population using simple random sampling, and now we got to use the formula for when we say, okay, well, we got n1 times point estimate 1 times 1 minus point estimate 1. We want to see if it's going to be greater than or equal to 10. So here we have 1252. We're going to multiply that by 174 over 1252 times 1 minus 174 over 1252. And we want to see if that's going to be greater than or equal to 10. Okay, plugging this into our calculator, we're going to get 149.84. So we know it's going to satisfy that condition. Okay, next, what we want to do is we want to be able to find the value for the females. So we have n subscript 2 times point estimate 2 times 1 minus point estimate 2. We want to see if that's greater than or equal to 10. So we know we have 1337 times 128 over 1337 times 1 minus 128 over 1337. I want to know if that's greater than or equal to 10. So when we multiply that all out, we get 116.03, and we know it's going to satisfy that condition because it is greater than or equal to 10. Okay, so now we need to find the critical value. So the critical value, we know up here it's telling us that we're going to construct a 90% confidence interval to judge whether the proportion of males that have at least one tattoo differ significantly from the proportion of females that have at least one tattoo. So we're looking for the critical value where it's Z alpha divided by 2. So what do we need to do first? Well, we know that alpha is going to equal 1 minus that 90%. That's 0.90, which gives us 0.10. And then we're going to take alpha and divide that by 2, so we know that this is going to be 0.10 divided by 2, which is equal to 0.05. Now, just to give a brief description of what this would look like, okay, what that means here is that we want to find this critical value, right? And that critical value is going to be here, where this is 1 minus 0.05, which is 0.95% here, and this is 0.05. So we're looking for the critical value there. So we're going to use, we can either use the table, which can take a little bit longer to be able to do that. We've done it in the past. Or we can use the function INV norm on our calculator. Okay? Now remember, when we want to find the critical value of Z, we need to look at the area to the left because we're looking for this critical value here, Z alpha divided by 2. So we have 0.95 as our area. We know that our mean is 0 and our standard deviation is 1. So let's find out what our critical value is going to be on our calculator. So let's go ahead and do that. So we got second distribution. We're going to go down to INV norm. I'm going to put in our area of 0.95. We have our mean of 0, standard deviation of 1, and then select paste. And then go ahead and press enter. And now we have our critical value. Okay, so again, this is just a review of being able to find the critical value. So if you notice here, we can round that to 3 decimal places, which is 1.645. Okay, so now we've been able to find the critical value for this particular problem. All right, now what we're going to do is in step 3, okay, what we're going to be able to do is we're going to be able to find the lower bound and the upper bound by plugging in this information. Okay, so let's go ahead and do that. So we have the lower bound and then we have the upper bound formula. Okay, so let's go ahead and do that. So for the lower bound, we're going to take our point estimate 1, which is 174, and we're going to divide that by 1252 minus 128 over 1337 minus the critical value of 1.645. And then we're going to multiply that by, again, the point estimate for 1, which is 174 over 1252 times 1 minus 174 over 1252 divided by N1, which is 1252. And then plus, we have 128 divided by 1337 times 1 minus 128 over 1337, and then we're dividing that by 1337. Okay? So let's go ahead and do that. All right, we're going to go ahead and first take the square root and then multiply it by negative 1.645 and then add the following. So we're going to kind of go in reverse here by using order of operations using the calculator. Okay, so we have second square root. Okay, we're going to put this in entire parentheses. So we're going to contain this in entire parentheses. And then this is going to be in parentheses. So we have parentheses, and then in our numerator, we have another parentheses of 174 divided by 1252. And then we're going to multiply that by 1 minus, again, parentheses, 174 divided by 1252, parentheses. We're going to close the parentheses of the numerator, and then we're going to divide it by 1252. Okay, and now we're going to add, again, parentheses, and then parentheses again, 128 divided by 1337 times 1 minus parentheses 128 divided by 1337, close the parentheses, and then we're going to divide that by 1337, close the parentheses, and then we're going to go ahead and select enter. Okay, now we're going to multiply that by minus 1.645. So we're going to multiply that by negative 1.645. Okay, and then we're going to add this. So we're going to take parentheses and then another parentheses, 174 divided by 1252, and then minus parentheses 128 divided by 1337, and parentheses, and hit enter, and then we get the following result. So we can say that the lower bound is going to give us the following result, and if we round that to 2 decimal places, or 3 decimal places, excuse me, we get 0.022. Okay, now let's go ahead and find the upper bound. So for the upper bound, we're going to get the same result here, same formula. Only thing here is that we're going to now add the information to the right. So let's go ahead and do this. So let's go back up here, and we know that when we actually calculated this entire result, right, we end up getting this value. And then what we're going to do is we're going to multiply that now by positive 1.645. 4, 5, and then hit enter. And then we're going to add this since it's in parentheses. So parentheses, second parentheses, 174 divided by 1252, and then minus parentheses 128 divided by 1337, and then we get the following amount. So let's go ahead and copy that result. So this is the upper bound, and so if we approximate that to 3 decimal places, we get 0.064. Okay, so what does that tell us? Well, that tells us that the confidence interval, okay, has a lower bound and then an upper bound, and that lower bound is 0.022, and the upper bound is 0.064. Okay, let's go back up here. Okay, remember here that it says that, and let me copy that. It says here that if the confidence interval, okay, does not contain 0, conclude there is sufficient evidence of a significant difference between proportions. So if you look at this confidence interval, is 0 in there? Okay, it does not contain. So therefore, if it does not contain, then we're going to say that the following. We can say that the confidence interval does not contain 0, so we're going to conclude that there is significant difference between the proportions. Okay, so now we can state our conclusion. We can say that there is 90% confidence that the difference of proportions is in the interval. We conclude that there is a significant difference in the proportion of males and females that have at least one tattoo.